this workflow I wanted to present is for the EPN. Okay. It's a vehicle activity workflow, and it allows the managers to review fleet and vehicle usage through a dashboard. And the first workflow is the fleet summary. It gives an overview of the entire fleet, showing all vehicles in one place. And then we also have a second workflow that's related to it that lets you focus on a single vehicle, so you can drill down to a specific detail. The first one, just to talk about it, this workflow pulls the vehicle log event from here and generates a dashboard that exists to answer one question, and that is how long, how is the entire fleet doing? That means how many vehicles are actually in circulation, how far they've traveled together, and how fuel they've used. Right, just to see what the dashboard entails. They are made up of 3 categories. The cards, this shows the total aggregates of the entire fleet, such as the total number of vehicles, total trips, total kilometers covered, and etc. And we also have a table, a summary table that shows the full trip summary. And then lastly, we have 2 charts that would compare the total distance traveled per month and the number of trips per vehicle. And then the second one uses the same pipeline as the fleet summary workflow with one additional steps. It filters to a specific vehicle using the license plate. It includes views that are not available in the fleet summary dashboard, which is the driver's history, which shows who was driving the vehicle, and also the refueling history, which shows how and when the vehicle was refilled. Yeah. And just to see an overview of how the dashboard would look, it's made up of 3 categories, 3 metrics, 3 categories metrics. We have total trips, total kilometers traveled, total fuel consumed, and also have tables that would summarize driving ranking, summarize the trip by drivers. And we also have a vehicle usage containing the complete history of the selected vehicle, and also a table that would show the refilling, which entails columns like when it was refilled. Yeah. And then lastly, we have a table that would show the vehicle kilometers traveled over time. Yeah. And just to show you how it looks, let me just go through the first one. This is the fleet summary. Basically, it's made up of like this show. Like I said, the number of cars are 7. This shows the total number of vehicles used, total trips, total kilometers traveled, total fuel used, and then we also have total diesel used, total petrol used, and then occupants per trip. Okay. And then we also have a table that would show a trip summary per vehicle that would entail license plate for the number, the start and the end, the oil consumption, the type of oil, the objective, the origin and the destination, and the total distance covered. And then lastly, we do have the 2 bar charts that would compare the distance traveled per vehicle, and also the number of trips done by vehicle. Okay, and if you want to narrow down to a specific vehicle, then you would have to use the vehicle summary workflow, which is similar to fleet summary, but only that you have to specify in the config the license plate. And then it would be able to narrow down and then be able to get a specific detail for that specific vehicle, like total trips covered, kilometers covered, and then the consumption in liters, and then the average occupants in that car. And then this makes it different from the other one because it has these are the two tables that it has. The ranking, the vehicle ranking. This summarizes the trips by driver. You should be able to see which driver has driven the car the most, and also the usage of the vehicle, similar to the fleet's summary. And lastly, the fuel refill table that would show when it was refilled, the station, the type of fuel, the liters, how many were refilled, and then who was responsible.
All right, well, why don't we turn over to Sam to check out his new drone workflow.
Okay, so can everybody see my screen? Good to go. Cool. So basically, we use DJI drones here at our site, and the drones record a lot of data locally on the controller in text files. The thing is, those text files are encrypted. So this workflow works in 5 steps. You configure the workflow through the form that I'll show. Then it runs, it decrypts, and passes the encrypted files. Output is a JSON and a KML that you can open in Google Earth. This is tapping into the work. It's an open source repo on GitHub named DJI Log Parser. So it uses the work done there to decrypt and parse the files. It extracts the flight data and then pushes it to EarthRanger. There's kind of 2 groups the data goes into. One is an event type. Those are the flight logs. And the other one is the actual GPS tracks of the flight. So this workflow then can be configured to do both or just GPS tracks as ingestion into EarthRanger. And then there's a dashboard that comes out on the Ecoscope platform. So going through the form quickly, can name your workflow, the data source, EarthRanger, connect to your EarthRanger instance. The DJI API key is what you need to do as a configuration before all of this. It's free to get at developer.dji.com. Just register. The details are on the GitHub repo for this workflow. So you just follow those, very easy to get. So you paste that in. That is what is used to decrypt the flight logs that come from the controller. Then the flight logs folder. So you point the full path to the folder containing your exported flight logs files. The flight folio event type. So this is where that one category, the event type, which is the flight folios. So there's a little bit of setup if you want to have this on the EarthRanger as well. On EarthRanger admin, there's an event type that you set up. Again, instructions on the GitHub repo of setting that up. So the slug, the event type slug gets written in here. It's pre-populated already by default if you follow the instructions on the GitHub repo. So really the only thing you put in is a DJI API key, the folder path, and registration if your drone has a registration number attributed to it that you want to push through. Otherwise, the subject and the source, if it doesn't exist on your EarthRanger yet, it will automatically get created through this workflow. The subject type defaults to aircraft, the subtype to drone, and the source type to a tracking device. The DJI records at about 10 hertz. So that's 10 GPS observations per second, which is very high resolution. So here you can set it to, the default is 1 hertz, so 1 GPS point per second. And then the final one is flight defaults. So this is if you want to attribute the nature of the flight to the flight logs event type. These are the official flight categories: visual line of sight, restricted visual line of sight, extended VLOS, BVLOS or beyond visual line of sight, and BVLOS. If you wish to fill it in, it will get attributed to all the flight logs that gets processed in this batch. If you leave it open, then that field will be left open on the EarthRanger side. So that's a form. Let's have a look at the dashboard. So I processed 5 logs here. It took 3 minutes to process. Ingested, 2 logs got ingested. That means they went all the way through to EarthRanger. 3 got skipped. So I deliberately chose 5 logs, of which 2 are new ones, and 3 already exist in EarthRanger. So it detected that they already exist in EarthRanger and skipped them. So rerunning this workflow against logs that were already ingested is safe. They won't push the event type or the observations through again. And then if there's any failed, you'll see here the number that were failed, total time flown in those logs, the total distance flown, and the total number of aircrafts. In this case, just 1 aircraft. But you can mix the logs together in the folder, and it will run through them, creating, like I said, if that aircraft doesn't exist on EarthRanger yet, it will create it. A map, color-coded, so each flight gets its own color. You can see these little squiggly star-shaped things on the track. So that's actually where the drone stood still and then started hovering and turning and so on. So it's quite interesting what comes out. And then ingestion status table. So the name of the log. So this is a name auto-stamped by the DJI as it creates the logs. So you can see the flight record, date, and time of takeoff.txt. Aircraft serial number gets extracted. Takeoff time, flight time in minutes, battery percentage at takeoff, battery percentage at landing, battery serial number, the maximum altitude above ground level in meters, maximum speed, maximum distance in meters from home point, and then total distance flown by the drone. The firmware of the remote controller is also in the log, so that's also extracted because it's available. And the status, so you can see 2 got ingested, and 3 got skipped. This can also be downloaded as a CSV if you want to go through the ingestion logs. So from there, going to Files, Open Results folder. Let me see if I can bring that up. Window. There we go. Okay, so here's the folder. So you can see the injection status, HTML, the flight tracks, the map, and the KML files that gets generated, along with the pixie.log and the results. So if I open up in Google Earth, I'll show you the KML, what it looks like. There we go. So you actually get the 3D view of the actual flight, which is pretty cool. And then going over to EarthRanger, what it looks like on the EarthRanger side. Share. Okay, I think my EarthRanger view is on now. So on the right here, you can see the drone on the map and the track of that drone as it flew. You can see it flew slowly there and then sped up. The points are further along from each other, and also where it stood still and did its little look around. And then on the left here is a flight folio event type that gets generated. So takeoff location, takeoff date, time, flight identity, auto-populated, the aircraft serial number, the aircraft registration. If you chose to type it in, it will come through here. Flight key is a combination, it's a unique ID of this flight, combination of the aircraft serial number and the takeoff date, time. Timing, flight date, the duration in minutes, start time and end time, battery at takeoff, so battery percentage at takeoff, battery percentage at landing, battery serial number. Performance envelope is a maximum altitude above ground level. these are the stats that we saw in the ingestion status table on Ecoscope that come through. So max speed, max distance from home, total distance. This is user filled for now. Journey from, so if you want to say from where to where you flew, the nature of the flight, those flight categories, the remote pilot name. So what's nice here is it's set up as a dynamic field that taps into the user list, the existing user list on the EarthRanger instance. So it just removes the human error of typing in and spelling mistakes and so on. If I'm right, the Ecoscope web will be able to pull that list as you fill in the form. I'm talking under correction, but hopefully that will be the case. And then home point, latitude, longitude, and firmware version. So yeah, that's the workflow end to end. Just a couple of stats. So wanted to push this to its limits. So we took the over 1,000, so 1,182 logs from one of our drones and let it run overnight. So it ran for 7 hours. The one workflow ran for 7 hours, ingested all those flights. It's a total of 353 hours, 5,400 kilometers. And yeah, and we've tested it with the two drones that we have on site, and it's been working pretty well as long as it's a .txt flight record. There you go.
Awesome. Thank you, Sam. That's incredible. Yeah, really well done. Do you have any comments on the process to create the workflow and how you did it?
Yeah, so it's a little bit of head scratching in the beginning, but taking the cue from the Wildlife Dynamics workflows on GitHub, kind of seeing how it should look, and then reverse engineering that into something that Claude Code can understand and kind of guide the thing. So you get some results finally, and then it starts working.
Yeah. Okay. Yeah, would love to hear maybe after this call or on the forum, just more feedback around the development process and how we could improve that as well. And our SDK, is under active development. So really value your insights into this process. Cool. Well, thank you so much. Charles.
Yeah, thanks, Sam. That was really interesting. Just one quick question. You might have said this, but I was absorbed in other details and maybe didn't catch, but where are the flight logs being, the API key is pulling the DJI API directly, and that's where it's stored. DJI has its own API, and they're stored on that API. Is that correct?
Yeah, so the API key allows you to get the decryption key from DJI per log, and then it uses those keys then to decrypt each log individually.
Gotcha. And then the logs themselves are, where are those stored locally on your machine before you?
Yeah, so they natively get stored on the controller itself or on the mobile device if you're using a mobile Android device with the DJI app on it. Mm-hmm. So transfer them to the machine, and then it's just a little bit of housekeeping of which files and so on.
Right.
Where you put them and just point them to the right folder.
Cool. Yeah. That's great information. Transparently, we're trying to figure out, how to provide this type of rich functionality on the web app, and we're figuring out the timelines for that. So particularly when there are data sources that are not EarthRanger, I'm trying to just figure out where are those coming from? How could we stage those on the cloud so they would be available, that kind of thing. So thanks for that information. Looks like Arky's up next.
Cool, Sam. Kudos. I have a question about why you didn't choose patrols as an option. Adding the tracks as a patrol with the subject that has that would be a drone name, and extracting events. Now, these events could be the images that the drone has taken, and attaching them to the petrol. So I'm interested to hear why you don't take that approach to do this. But nevertheless, I'm really curious to hear, curious to see like this methodology. Thank you.
Yeah, no, great questions and great points. The honest answer is I just wanted to get it working, and this is the first steps of getting it working. So yeah, bucketing it into a patrol window, and the photos, I think Tevin did a demo of attaching photos to an event type. Yeah, just a couple of things to figure out, I guess. So event type created, you would have had to create that event type at the time of the photo taken, which is a bit tricky given the hardware you need to, you have a phone to create that event type. Yeah, great questions, and I think definitely worth looking into.
Great. Chris?
Really quick, Sam, did you happen to explore any options for pushing that data from the controller up to the cloud?
Yeah, I'm scratching the surface. It seems to be possible. That's kind of down the line. I wanted to spend more time looking into that, but scratching the surface, yeah, looks to be viable.
Great. I know that they've done a lot of work to update their cloud API and even host it themselves. So I'll follow up with you after this, and maybe we can partner on coming up with a solution for your case and everyone else. Thanks, Sam.
Awesome. Thanks so much, Sam. So we'll turn over to Tevin, who's going to present on a new workflow to do animated tracks. Oh, sorry, Yun.
Oh, I see Alka has a question on the chat. Really cool. Will it be possible to make these workflows available for other Ecoscope users as well? Sam, do you have an answer to that?
Yeah, no, it's you can use it right now. The GitHub link I'll post in the chat, and then you on Ecoscope desktop, you paste that link in, and it will load the workflow for you. They're actually really easy to get started. Yeah.
Great. Thank you. Awesome. So yeah, over to Tevin to present a workflow that he and I have been working on animating subject tracks, and he's going to demo a data set on the Mali elephants. So over to you, Tevin.
Okay. Thanks, Jake, once again. So the animated tracks, what Jake and I were trying to do was to just bring life to the subject tracks that we have, because we do have the default 2D tracking maps where you get to see the movement of the subjects over a given terrain. So the way we did the workflow, we just had a couple of steps where you connect to EarthRanger for now, but I think in future we'd also support more options, or rather more sources to connect to, and then you define your time window. Then once those have been defined, when you run the workflow should be able to pull the observations, build trajectories. And in this process where the trajectories are being built, there's a separate task which now creates a trips layer, which will now overlay on the map to show how fast or how slow the subject was moving over the terrain, and then have an animated HTML file, which optionally could also have an MP4 as an output, and finally give you your dashboard widget. So basically it's just an animation, but then using PyDeck, we are able to bring that to life. So what goes in, just as I defined above before, is you get to connect to EarthRanger and define your time range. You also have to enter the subject group. And on the config form, I think I'll show this as well, there's an option whether you'd want to have a video export for the animation. or not. And then on the output files, you get your relocations, your trajectories, the animated map, and the animated video. So going through the workflow stats quickly, we just used 24 tasks. Most of them are existing. We added a few, and there's a default video length, which is capped to 75 seconds. But I'll expose this to just allow you to define how long you'd want your animated video to be. Or if not, you can also just leave it as it is, and the animated video will just be capped to how long the actual animation is. And so the environment took at least 350 MB on the runtime environment. Then we just made, we utilized the deck GL trips layer for rendering. We also incorporated the terrain tile streaming and an optional headless Chromium for video export, because to convert the animation to video, we had to run on Chromium and use Playwright to just generate the whole video. So allow me to just go to the config form and show you how it looks like. So when you come to the workflow configuration section, we do have these default cards that will always exist in almost all the workflows, where you get to just set your workflow details, connect to EarthRanger, define your analysis time range, and then you can also enter the subject group that you want to use. So if you have elephants or giraffes, vehicles, whichever subject group that you're comfortable with, you can as well as input it here. And then for this section, converting locations to trajectories, we do have the advanced option, which allows you to now just configure based on the subject group that you've defined over here. And then we do have the configure terrain elevation decoder, where you have the exaggeration factor, which allows you to stretch the terrain layer based on the factor that you'd be comfortable with. So by default, it will always be 1. So it will just render the terrain as it is. But if you'd want to modify it, you can as well as do it here. And then for the map view bounds, what this does is it just allows you to set the camera, the view of how you'd want to see the subject. So by default, the pitch is set at 45, which means the view will be at an angle, at a 45-degree angle. And if you'd want to just see it from the top down, you can set it to 0. Great. So heading to the configure animation settings, there are multiple configurations, but the one that I exposed, since we thought it would be important, would be the animation speed. So this just defines how fast would you want your animation to be. If you want to see how the subjects move across the terrain at a much slower pace, you can actually just reduce this value. And if you want to see how fast they move, you can as well as just increase it over here. And then the draw animated map also has some configurations. So what happens here is if you leave this section unmodified, when you draw your map, you'll just get the tracks with a point layer, which shows you how the subject was moving across the terrain. But if you'd want to now add a GLB model, you come here, click enabled, and then enter a URL where your model sits at, and then define a couple of things such as the size scale, what's the size of the model, how big would you want it to be, and also define the minimum pixels and the maximum pixels. So this is regardless of whether you zoom in or zoom out, how big would you want your model to appear on the map. And then we do have the first heading option, which allows the model to rotate at any point when you get to when the track makes a curve or a bend. It's easy for the model to also do the same. Then so the yaw offset, the model pitch, and the model roll, these are just all parameters related to how you'd want the model to appear on the map. And the smooth samples is just meant to define how the lagging effect. of the model. Then the terrain pitch, so it should be able to adjust on whether you'd want to see it go through the terrain or not. And then, so physical based lighting. Okay, this is just about shading. And we also have an option to use the track color, which means the model that you have, the GLD model that will be on the map, will also use the same color that the subject had on EarthRanger. And then finally, if you'd want to get a video as well for this animation, you just come here and enable it. Yeah. So let me go to just one that I had run earlier, and here's the output of the workflow. So as you can see, the minute you just render it, the animation just starts moving, and you get to see your subjects move over the terrain.
Tevin, can you zoom in and go to a 45 degree? You can see that this is the navigable, and you can hold Command or Option down and then turn the pitch of the terrain.
Yeah.
So if you can find a 3D model of your subject somewhere on the internet, you can substitute obviously from the elephant, but
yes. And sorry, Jacob. So to add, finally, the good thing about this is once the animation is done, each track layer starts fading away to just show you how much time has passed since the subject was able to move at that particular point. So the fading effect can also, I can expose that as well. If you'd want to just have it as it is, it will be retained. But then over time, if you'd want to see how far or how long the previous point was visited, you'd get to see it through the tracks as it gets to fade and gets a bit lighter over time. Great. Any questions?
awesome. Thanks, Tevin. And then the camera icon, you can actually click that at any point in the animation and it'll effectively screenshot what's happening and save it as a PNG. And Tevin, do you want to show the MP4?
Oh, yes. So for this workflow, I didn't enable the MP4, but I did it on a separate one. And when you go to the files, open results folder, you should be able to get now all these outputs, your relocations, trajectories, the map, and the animated MP4, which is basically this. But I did use a different setting for this, so the model looks a bit off. But this is how it looks like. Then finally, if I get to go towards the end, you can see the tracks start to get lighter on some of the visited spots for each subject.
Awesome. Thanks so much, Tevin. Arki, your hand's up.
Hey, that is super cool. Thank you so much. I have a suggestion.
Yes.
I understand that you are using Playwright and headless browser to export. I have a faster way. It's been 6 years since I worked on it, so I don't know if it still works, but you could use something called Web Codec API. What it allows you to do is to use your hardware GPU to do the export. So you'll be doing like it very fast. And if you're using something like a Rust WASM, you don't need anything else. So it's going to be super fast export directly. And you might even get like near playback time recording. So just a suggestion, reach out to me. Love to play to see if this web codecs work. Thank you.
Great, thanks.
All right, let's just see if Deven has been able to join. Deven, I'll hand over to you. So Devin's a student at University of Washington, and he's been working on a set of tasks in Ecoscope for temporal trend fitting, and then has applied them to and created a deforestation workflow that he'll show. So Devin, if that's all right. Otherwise, maybe Zach can present on your behalf, but let us know.
Yeah, my device is kind of all over the place right now. Zach, if you can pull up the Ecoscope, the GUI for the forest cover workflow, that would be great. And we can riff from there. So yeah, essentially, like Jake was saying, I started working with him at the start of the year, understanding that there was a need for a more advanced trend analysis module based on some previous work with generalized additive mix models that Catherine Villanueva had started last year. And so essentially, in terms of working on these trend analysis pipelines, we kind of built out a system that started with basic linear regression curve, and at each step kind of relaxed one assumption, whether that was like the distribution of data we were working with, or using multi-site characteristics to kind of inform our model fit and prediction estimates. And so beginning with the linear regression class, we expanded to a generalized linear model, a generalized additive, and a generalized additive model, which added random effects and signal and noise that you can kind of see within this top plot here between the trend confidence marks. And finally, a generalized additive mix model, which is now just being added to Ecoscope. And I'll talk about that in a little bit. Essentially, what happens here is that the user is able to input some kind of area of interest or regional classification. Commonly, this is in like a Parquet file that essentially draws the boundaries for a region that we're trying to study. We communicate these data points and connect to Google Earth Engine for the Hansen forest cover data set. That's a data set spanning, I think, between 2000 and 2024, but quite possibly even further back than that. And yeah, like you can tell in setting these workflow details, we've kind of gone through this a few times, but you can connect to Earth Engine, specify the time range you want to study within this Hansen data set that's already loaded over there. And you can group by category. Most of the time it's region of interest, and like I said, specify that Parquet file. From there, you can analyze the forest cover for this data set. So now that you have the area of interest and the actual Hansen cumulative forest loss over the past 2 or 3 decades or so, you're able to generalize the plot, produce the plots that we have that we've displayed before that, before the screen. That will essentially show within like a 95% confidence interval the general trend of these data points in the last 20 years and where it's going for future estimates. We're using a generalized additive model, like I said, because it adds random effects. And so, right now we're doing forest cover, but if you were to apply this to like an animal migration pipeline, or I think elephant walking speed is another one that I'm working with on the side. Essentially, you're able to tell that if, in one area, let's say Mount Kenya, the forest cover is declining at a steady rate, but in Mount Londiani, you have a sudden regime change that takes effect, whether that's, a lack of precipitation for a few years, or, excessive logging or something like that. You're able to kind of use similar site characteristics using this generalized additive model and extending to the generalized additive mix model to kind of inform these predictions, so that if there's a sudden regime change happening in 4 out of the 5 sites that you're studying, and you want to look closely into, like I said, the Mount Kenya site, if there's a regime change happening in these other areas, that kind of informs the prediction and fit models for the Mount Kenya site as well. So, it's especially helpful if you have sparse data sets for something like forest cover, but also getting better at predicting those kind of unpredictable events that are specific to like ecological environments. A note about the generalized additive mix model. We initially used we piped in the MGCV library from R, which is essentially like the industry standard for creating like mixed generalized additive models. But that's a really heavy dependency, so we switched to using Bambi in Python. That's a Bayesian model building interface that has proven to be pretty well suited to these kinds of environments. And so after setting all these configurations, you can generate those plots if you want to navigate to that Zach, and that'll show you the trend of the forest cover data set we're working with, and hopefully extending to other dashboards as well.
Nice. So this is the survival curve, and the trend fit from Deven's model is the green area, showing and then the prediction error on that curve as well. So just some background, this is a data set from or an area of the Masai Mara in Kenya, and you can see all of the different forest loss that's happened up on the escarpment. But this is showing you the quantitative trend in forest loss starting in around 2012. Awesome. So thank you so much, Deven. And this has been a really amazing contribution to the Ecoscope task library, is that trend fitting and yeah, amazing work. Thank you. Does anyone have any questions for Deven or others? Cool. Yeah, Charles.
Yeah, it's more of a comment. Well, first of all, thank you everyone who presented. And I just wanted to echo your comment from before, Jake. I think everyone who's presented today is really on the cutting edge of workflow development. And I'm sure that there has been some struggles, as you mentioned, Sam, like if it's a new SDK, and I'm sure there's learning curve to it. So to whatever extent you feel you have the time to put on the community forum, even very briefly, like, how you worked around any issues and stuff, that I think could be very valuable to the community. So just echoing Jake's comment from before. And thank you everyone for presenting and working through all of the rough edges as we're getting this off the ground.
Thank you. Katie.
Yeah, I just wanted to say, yeah, those are all super interesting, super cool. I'm looking to make, some of my own flows soon, but I was intrigued really by the last one about, I've never heard of, well, a little bit of those type. I didn't know you could maybe do some sort of potentially predictive modeling. And so I was curious if that was accessible on somebody's GitHub somewhere so I can look at it, or if not, if you have a post on the forum that I could look at. But I'm definitely going to be looking into those tools, but that was super interesting. I don't know if that's a question really, but.
Yeah, no, absolutely. That deforestation workflow is public. We are still, Deven's just checking in some changes, as he said, from the reliance on the MGCV library in R to the PyMC library in Python. So once those are checked in, then we'll hopefully get that posted as one of the kind of standard workflows. And Sam.
Yeah, hi. Thanks for all those really, really great examples. My question, not surprisingly, is about the last one. Sorry, I wasn't quick enough on the button about the GAMs. So when you sort of switched from MGCV to Bambi, did you do some sensitivity testing? Because you said, yeah, it was a heavy lift to get the MGCV working nicely. So I was just curious as to how you sort of compared the two and what came out. Thanks.
Right. Yeah, there was definitely a heavy lift. The kind of main difference I see is with how they approach the multi-site fitting specifically. So with MGCV, you would be able to put in and normalize like the different data frames for each of the various sites that you're inputting. But it would really only draw like a single trend line through the specified plot we had. With Bambi and this Bayesian approach, you could kind of mess with some of the spline calculations. So the splines are, I guess, the smaller lines between data points that kind of measure this trend. And so you could mess with some of the formulas that actually go into that. The splining is automated for the MGCV. The spline and smoothing parameter choice is automated in the MGCV library. With Bambi, it draws a full it draws all these posterior chains and samples based on, I think, 500 to 1,000 to a kind of n or variable amount of splines that you can draw to essentially get a full, to measure the full posterior distribution of the fits and how well the smoothing parameter fits the data set in question. And so actually that approach is a little bit preferred because it's more empirical in nature. And we used something called Laplace as our kind of our fitting family, I guess, for the Bambi approach. But in terms of actual testing, running on, I think, the 9 forest cover data sets that I had access to, I did notice, I guess, value and output wise, the forest cover estimates decreasing overall between the MGCV library and the Bambi library, which is something I looked into. And that's because I'm talking about the Mount Kenya site specifically right now, but with the MGCV approach, its confidence intervals were bounded too greatly. And so the estimates were actually rising to, I think, about starting in 2002 or something, rising to about 405,000 acres, I guess, of forest cover. Those units need to be fixed up a little bit. And it decreased by about 20,000 for the same time period when we switched to Bambi, and that's because of these samples that it was taking rather than a more generalized smoothing parameter that we didn't have control over.
Yeah, super cool. Thanks for that comprehensive answer. I look forward to dinking with the workflow.
Yeah, no, thanks, Devin. And Sam, would love to pick your brain on this as well. Things was using information criterion to select the optimal number of splines as part of the sort of automated fit, but whether that's the best approach or not, but would love to discuss that further with you.
Yeah, be great. I'm game.
All right. Well, we're on the hour, so I think we'll stop there unless there's any other questions. And thank you very, very much for attending. And just a couple resources here is our community forum channel. So please sign up on the Ecoscope channel if you haven't. And hoping people can ask questions and get sharing workflows and everything Ecoscope related on there. Plus our website, which is always being updated and with SDK releases and documentation changes. So you'll find more there as well. Yeah, so thank you very much, and look forward to, we'll try and do these fairly regularly, maybe once a month or once every 2 months, but yeah, we'll be in touch and announce sort of the next date. And sorry to anyone that is watching the video after this, if you weren't able to attend in person, because I've picked a bad time, but we'll try and get there with a good time for everyone.